Assalamualaikum and hi everyone. In this video, I am going to explain how to write the mechanism for free radical substitution. So let's start. First, you have to know what is indicated by arrows in mechanism. Is half-headed arrow. So, this arrow indicates the movement of electrons. So, the tail of arrow indicates where the electron comes from. So, usually the electron comes from bond. While the head of the arrow indicates where the electron goes. So, usually it will go to more electronegative atom. So I will show you an example. So in this compound, if we have this type of arrow, this arrow shows that the electron comes from CBr bond and the electron will go to Br atom. So as we can see here, it is half-headed arrow. So it means that it only involves the movement of one electron. So in this case, for half-headed arrow, usually it will form free radical. Then if we have full-headed arrow, so sama macam tadi, the tail of the arrow indicates where the electron comes from. So usually it will come from bond, and the head of the arrow will move to more electronegative atom. So as we can see here, this is double-headed arrow. So it involves the movement of two electrons. So I will show you another example for full-headed arrow. So the electron comes from CBr bond and the two electrons will move to Br atom. So in this case, this will break the CBr single bond. It will form carbocation. And Br-. So untuk contoh yang atas tu tadi, kalau half-headed arrow dia menyebabkan penghasilan free radical. So kat sini dia. So in this example, so usually it involves the breaking of bond, but one electron will go to Br atom and the other electron will go to carbon atom. So it will form free radical of carbon and also free radical of bromine. So the different case from the bottom one here, where it involves movement of two electrons, so it will break bond and the carbon becomes positively charged, and since Br accepts two electrons, so it will become Br-. So now let's go to mechanism in example 3. So cyclopentane undergoes bromination to form bromocyclopentane, and you have to write the mechanism for this reaction. So first you have to write the equation first. So the mechanism here, so we have to show the mechanism to show how this product is formed. After undergo bromination. So in free radical substitution, there are 3 steps. The first one is initiation step. So this one involves the breaking of bond of halogen molecules. So for the first step, one electron will go to one Br atom and the other electron will go to the other Br atom. So in this single bond, there are 2 electrons. So one electron goes to each atom, so it will become Br dot. This is free radical of bromine, or you can write it as 2Br. So the first step involves the homolytic cleavage of bromine molecules in the presence of sunlight. So now let's go to the second step. So dalam second step ni ada dua pula step. So using the free radical we have from the first step, so it will react with cyclopentane from the question. So for this mechanism, you have to show the carbon-hydrogen single bond in cyclopentane so that we can see the movement of electrons. So you can choose any carbon atom from the cyclopentane. So let's say you choose this one here. So you have to show the two hydrogen atoms on this carbon. Okay, so what happens here? One electron from CH bond here, so this is carbon, right? So satu electron daripada CH bond ni akan combine dengan free radical bromine daripada first step tadi. So kita lukislah. Serahkan elektron tu, so dia akan meet somewhere in the middle. So satu elektron daripada CH bond akan gabung dengan Br dot. So kat sini akan menghasilkan HBr. So dekat carbon hydrogen bond ni tadi, satu elektron dah pergi combine dengan Br dot. So ada satu lagi elektron pada bond yang tertinggal, so dia akan pergi kepada carbon atom. Ini kita akan dapat hasilkanlah free radical of cyclopentane. So lukislah dot kat sini. So tadi ada 2 H, sekarang tinggallah 1 H. H ni tak tunjuk pun tak apa. So bahagian kiri ni je kena tunjuk hidrogen ni supaya kita boleh nampak pergerakan elektron tu. So that's for the first one. The second part in propagation step, just copy the free radical of carbon you got from the first part. So lukis balik je lah. So it will react with bromine molecule. So macam first step tadi, free radical akan combine dengan molekul cyclopentane. Untuk second part in propagation step, free radical carbon ni pula akan bertindak balas dengan molekul bromine. So satu titik ni menunjukkan ada satu elektron ya. So this electron will combine with one electron from the Br bond. So kat sini dia akan gabunglah menghasilkan satu single bond baru. So kita akan dapat cyclopentane. Hidrogen tu tetap ada. Sekarang carbon ni akan menghasilkan satu bond baru. Tadi ada satu elektron, dia combine dengan satu elektron daripada Br. So dapatlah single bond Br. So satu lagi elektron akan pergi kepada bromine atom. So kita akan dapat Br dot. So that's for propagation step. Now we go to the last step, termination step. So termination step ni melibatkan reaction between free radicals. So there are two free radicals yang terhasil daripada first step from initiation step and also from propagation step, which is Br dot and the free radical of cyclopentane. So kita akan gabungkanlah Br dot plus Br dot. Cyclopentane, free radical of cyclopentane react with free radical of cyclopentane, and the last one, the combination of the two free radical of cyclopentane and the free radical of bromine. Now let's draw the product. Untuk termination step, kita nak hapuskan free radical, so kita kena gabungkan kedua-dua free radical yang ada ni lah. So So this dot indicates one electron, this one also indicates another electron. So combination of two electron akan menghasilkan another new covalent bond. So kita akan dapat Br-Br ataupun Br2. Akan menghasilkan Br2 molekul lah untuk yang pertama ni. Untuk yang kedua ni, gabungan antara dua free radical of cyclopentane. So kita akan menghasilkan new covalent bond between the two cyclopentane. Letak je satu covalent bond antara kedua-dua tempat yang ada titik tu. Okay, and then the last one, the combination of free radical of cyclopentane and free radical of bromine. So just form a covalent bond with Br. So this is the final step. So that's all for free radical substitution mechanism.